Hello my dear student, మీకోసం మీ భాస్కర్ సార్ physics in my life part 3 continuation. Another problem. If velocity of a particle is given as v equal to 3t square plus 2 meter per second. If velocity of a particle is given as v equal to 3t square plus 2 meter per second, then find the displacement. Of a particle from t equal to 1 second to t equal to 2 seconds. Okay, clear? If a velocity of a particle is given as v equal to 3t square plus 2 meter per second, then find the displacement of a particle from t equal to 1 second to t equal to 2 second. So we know that according to instantaneous velocity, particular time are given, so we can apply the instantaneous velocity formula. We know that v equal to dx by dt. So we can write dx equal to v into dt. So limits are applied. Initial position x1 and final position x2, and initial time t1 and final time t2. So integration dx is nothing but x according to mathematics form. Integration x power n dx is nothing but x power n plus 1 by n plus 1. Integration dt is nothing but t we can write. So we can apply formula. Integration dx is nothing but x. Limits can be written x1 x2 upper and lower limits, that equal to integration t1 to t2. V is nothing but according to statement given 3t square plus 2 into dt. So that we can write upper limit to minus lower limit x2 minus x1, that equal to upper limits time taken, lower values 1 second, t2 equal to 2 seconds. So that in 3 is nothing but constant, we can write outside. Why? Because we cannot apply the integration for constant. So that 3 t square is nothing but in the form of x power n dx, that x n plus 1 by n plus 1. We can write t cube by 3, and limits are applied 1 to 2, that plus 2 into integration dt is nothing but t, that limits are also applied 1 2. So that x2 minus x1 equal to 3 get cancelled. T cube is nothing, upper limits we can write 2 cube. 2 cube is nothing but 8 minus 1 cube is nothing but 1 plus 2 into t is nothing but 2 upper limit minus lower limits 1. So we simplify x2 minus x1 equal to, difference can be written 7 plus 2 minus 1 is nothing but 1 into 2, that equal to 9 meters. So x2 minus x1 nothing but displacement of a particle according to statement is given as 9 meters. Okay, clear? Once more, if a velocity of a particle is given as v equal to 3t square plus 2 meter per second, then find the displacement of a particle from t equal to 1 second to t equal to 2 seconds. Here limits are highlighted. So particular instant of time, so we can, particular instant time is nothing but instantaneous velocity. So according to statement v equal to dx by dt we can write. So that dx equal to v into dt, according to statement limits are given, we can apply. So like that in the form. Okay, next another problem. A body moves at a velocity, a body moves at velocity v equal to 2t plus 4 meter per second. Then find the average velocity of a body from t equal to 1 second to t equal to 2 seconds. But the body starts at t equal to 0 second from origin. So you can write a body moves at a velocity v equal to 2t plus 4 meter per second. Then find average velocity of a body from t equal to 1 second to t equal to 2 second. But the body starts at t equal to 0 second from origin. Okay. So finally we find out the average velocity we need. So particular instant of time are required. So according statement given. So we require the formula instantaneous velocity v equal to dx by dt. So we can write dx equal to v into dt. Limits are applied. Initial x1 and final position x2. Initial time t1 and final time t2. Integration dx is nothing but x. Already we written. So that x1, x2 limits are applied. So v is nothing but integration t1 to t2. V is nothing but 2t plus 4 meter per second and integration dt. So that upper limit to minus lower limits are applied. X2 minus x1 equal to 2 is nothing but constant. So we cannot apply integration. We can write outside. So integration t dt is nothing but in the form of x power n dx equal to x power n plus 1 by n plus 1. So we can apply the formula t square by 2 upper limits. T is nothing but according statement given 1. T2 is nothing but 2 seconds. So 1 2 plus 4 into integration dt is nothing but t. So integration 4 is nothing but constant, right outside. So integration dt is nothing but t. Limits 1 2. So is already the problem. X2 minus x1 equal to 2 get cancelled. T square upper limits and lower limits are applied. T is nothing but 2 square is nothing but 4 minus lower limit 1 square is nothing but 1. So plus 4 into upper limit to 2 is nothing but 2 minus lower limits 1. That x2 minus x1 equal to 4 minus 1 is nothing but 3 plus 2 minus 1 4. 2 minus 1 1 into 4 4, that equal to 7 meters. But x2 minus x1 equal to 7 meters, but we require the find out must be average velocity we find out. So that average velocity is nothing but change in velocity x2 minus x1 by change in time t2 minus t1. So average velocity equal to already we proved that x2 minus x1 equal nothing but 7. So that 7 by t2 minus t1. T2 is nothing but 2 minus 1 is nothing but 1. So that finally we get the answer is 7 meter per second. Okay, once more. A body moves at a velocity 2t plus 4 meter per second. Then find the average velocity of a body from t equal to 1 second to t equal 2 second. But the body start at t equal 0 second from origin. So according to statement times given. So we know that v equal dx by dt, instantaneous velocity basis we can write. So that dx equal to v into dt, limits are applied. So we have a problem can be solved. Next, Next one, we discuss about instantaneous acceleration. Already we discussed about instantaneous velocity. Instantaneous velocity is mean the velocity of the body at a particular instant of time is known as instantaneous velocity. Like that, similarly, instantaneous acceleration is nothing but at a particular instant time of acceleration of a body is known as instantaneous acceleration. For example, consider starting point A and the final position B. If a body travels with velocity v in t seconds, so some point we require the acceleration of the after t second, at a particular time t second we require the acceleration. The acceleration is known as instantaneous acceleration. Why? Because at a particular instant of time, acceleration of the body is known as instantaneous acceleration. So we can derive the acceleration formula. Let us consider velocity nearly v plus dv, and time also can write t plus dt. Small interval of time, microseconds are required. So we know that acceleration A equal to change in velocity by change in time. Change in velocity, final velocity is nothing but v plus dv minus v by t plus dt minus t. Tt get cancelled, vv is get cancelled. Therefore, A equal to dv by dt are A equal to dv by dt is known as instantaneous acceleration. A equal to dv by dt is known as instantaneous acceleration. We can also write the formula. So A equal to dv by dt is one of the most important formula. This also can be written that dA dt equal to dv also. So another formula, we can multiply and dividing with dx. Dx by dt is nothing but the rate of change of displacement is known as velocity. So a dx equal to dx by dt is nothing but v into dv. This also instantaneous acceleration. So you can write formula limits a dx is nothing but x1 x2. That integration v1 to v2 v dv. This is also most important formula used for object. Okay, clear? At a particular instant of acceleration is known as instantaneous acceleration. We can write v plus dv minus v by t plus dt minus t. So get cancelled. Total a equal dv by dt. So that can be written a dt into a dv. So that form can be written also with multiply and dividing with dx. Dx by dt is nothing but v. So v into dv, dx is nothing but so a dx. So limits are also applied in the form. Next, one problem. If a body moves initially with a velocity u, if a body moves with initial velocity u, if a body moves with initial velocity u and well, displacement x and displacement x, then acceleration of a particle given as a equal to root xk, where k is constant, where k is constant. If a body moves with a initial velocity u and is displacement x, then acceleration of a particle gives as a equal to root x k, where k is constant. Then final velocity of a particle becomes 3u. Then find the distance of a particle. So, according to statement, if a body moves with a initial velocity u and with displacement x, then acceleration of a particle gives as a equal to root xk, where k is constant. Then find the final velocity of a particle becomes to 3u. Final 3u. Initial u, final velocity 3u. Then find the distance of a particle. Then find the displacement of the particle. So, at a particular instant of time, there is no, at a particular velocity, initial and final position, acceleration also given. So, we know that according to instantaneous acceleration, a equal to dv by dt, we can write as dx by dx. Already we proved that a equal to a into dv by dx, dx by dt is nothing but v into dv, d is nothing but dx. So the required formula is ax into a into dx, that v into dv. Okay, limits. So limits are applied. Integration. So initial and final position, so not required. A is nothing but root 2 x. Root x is nothing but x 1 by 2 can be written. So x 1 by 2 dx, that equal to integration. Initial velocity u and final velocity is equal to, according statement, 3u. V is nothing but according to statement not there, so that v into dv. Okay, so simply integration, we know that integration x power 1 by 2 plus 1, because we know that x power n dx is nothing but x power n plus 1 by n plus 1. We can apply the formula x power 1 by 2, n is nothing but 1 by 2, 1 by 2 plus 1 by 1 by 2 plus 1, that equal to integration v is nothing but integration v dv is nothing but v. So like that integration v square by 2 integration x power n x. So like that formula, that v square by 2 into upper limits and lower limits are also applied. 1 by 2 plus 1 3 by 2. So that x 3 by 2 by 3 by 2, that equal to 1 by 2 is nothing but can be written outside. So that 3 upper limits are 3u. 3u square is nothing but 9u square minus u square. So lower limits nothing but u square. So we simplify the formula, that here constant also given here k. So that k is nothing but constant writes the outside. So that k. So finally we get the answer 2 by 3 k into x power 3 by 2. Okay, written as that equal to, so 1 by 2, 9u square minus u square equal to 8u square. 2 4 times get cancelled, 2 4 times 2 times get cancelled. Here x 3 by 2 equal to 2u square by 2 into 2 is 6u square by k, that x equal to 6u square k whole power 2 by 3. Finally we get the answer. So once more, if a body moves with a initial velocity u and versus displacement x, then acceleration of a particle is given as a root xk, where k is constant. Then find the final velocity of a particle becomes to 3u, then find the distance of a particle. So according to statement given, we can apply the instantaneous acceleration formula, a dx equal to v dv. We know that, where a is nothing but root 2 xk. Root 2 x is can be written as x power 1 by 2, can be written as x power 1 by 2. So k x power 1 by 2 dx equal to integration v dv. Upper limits are and lower limits are applied, so that we can, k is constant, we can write outside. X power 1 by 2 dx is nothing but in the form of x power n dx. We can write x power n plus 1 by n plus 1. So the simply x power 1 plus by 1 by 2 plus 1 by 1 by 2 plus 1, that equal to integration v dv in the form of x power 1. So like that, integrate v square by 2, upper limit minus lower limits we can also apply it. To simplify that, we can write 2 by 3 k x 3 by 2 equal to 1 by 2 8 u square. So 2 4 times get cancelled, 2 2 are get cancelled, finally 2 there. So that 1 is 2 into 3 6 u square by k, x equal to 6 u square k by 2 by 3.